Hey there, genetics students. In this video, I'm going to show you how to download your HVS1 sequence, show you how to clean it up, get the reverse complement of that sequence, and then get it ready for alignment with the reference sequence so that you can determine your haplotype. So the first place that you want to start is in your Blackboard classroom. And we're going to go to the Lab Information tab, click on that. Now I'm using last semester's classroom, so the dates aren't going to match yours, but that's okay. The information is the same. So we'll go to determining your mtDNA haplotype folder and click on that. And we want to download or open up three different things. So we want to go to the Day 2 handout and open that up. I'm going to open it up as a PDF. It doesn't really matter which one you use. And you also want to go to the specific day of your lab folder for the sequences. And we want to download two files. So let's say my unique identifying number is A8, and that'll be the sequence that I download. And you'll see that's just a bunch of letters. And you also want to download the PDF Flora Graham file. So A8 again, and this is the Flora Graham. I'd like to remind you of what you're looking at when you are working with your DNA sequence. Let's recall from day 1 of our lab that through PCR you amplified a segment of your mtDNA called the HVS1 segment, and to do that you used two primers, a forward and a reverse. Now your DNA is double-stranded, and the forward primer matched the sequence in your reference strand. Therefore it bound to the complementary strand. Then DNA polymerase extended the primer in the 5' to 3' direction by adding bases at the 3' end. And this gave us a copy of the reference strand. Now the reverse primer matches a sequence in the complementary strand, and it bound itself to the reference strand, giving us a copy of the complementary strand. Now this occurred many times over, giving us billions of copies of approximately a 500 base pair double-stranded section of your mtDNA. You then purified that PCR product and then added a sequencing primer that bound to the reference strand, giving us the sequence that you have before you. Let's see where the sequencing primer bound itself to the reference strand. Now we can easily see how our sequence came about. DNA polymerase extended from this primer in the 5' to 3' direction, giving us a copy of the complementary strand. Because the reference strand is what we will be comparing to, we're going to need to turn our raw sequence into its reverse complement. And I'll show you how to do that. Before we begin the process of making changes to our sequence, I'd like to explain the usefulness of the Flora Graham. So we're going to take a look at a Flora Graham here. Now the Flora Graham is a computer-generated printout of the sequencing process. Now we've converted it to a reverse complement from your raw sequence. So the ends that you see here in the beginning, when you look at your raw sequence, you're going to see those ends at the very end. If we scroll down, we're going to get to the actual sequence of the HVS1 segment. And you're going to see colored peaks. Now each peak represents a base, and each base is a different color. Recall that the dideoxynucleotides that were used in the sequencing reaction contain a molecule that fluoresces a specific wavelength when a laser beam hits it. This is how the computer knows the identity of the base. And so the way we use the Flora Graham is that we're going to clear up any ambiguous bases that the computer may have assigned ends to in the middle of the sequence. And if you do have ends in the middle of your sequence, and this particular Flora Graham is very clean, I don't think there are any ends in the middle. The peaks are very nice and distinct, and there are very few double peaks here. But if you do have ends in the middle of your sequence, you want to go to those places and look at the peak or the peaks associated with those ends. And you might be able to make a good guess by finding a peak that stands out more. Also, once you determine your mutations by comparing your sequence to the reference, it's a good idea to verify with the Flora Graham that it is in agreement with the base that's in your sequence. So just go ahead and check to see that you have a nice clean peak associated with that mutation, and then you can feel pretty confident in the mutations. Now the ends that are here at the beginning of this fluorogram and at the end of your raw sequence, they're simply the fact that there are many other reactions going on, many other gels being run at the same time, and some of those sequences may be longer than yours. And so the DNA polymerase was finished with your sequence, but again, there are longer sequences going through the machines, and so the laser beam associated with your gel is not seeing any more fluorescence, so it's just placing ends there. All right, let's get started on working on our sequence here. In the handout, you're going to find that we pretty much follow these steps. This is a great reference, and also you're going to want to have your handout open for when you need to go to websites. It's easy to just use the links from the handout. So let's grab our sequence now. We want to open up a new Word document and copy and paste the sequence. And we have to format the document to make the sequence work for us. And so the first thing that I'm going to do is change the margins. And I like to use a 3/4 inch margin on the sides and 1 inch on the top and the bottom. And then you see that tightens things up really nicely. The other thing you want to make sure of is that you don't have excess spacing, because that's going to throw things off. And as far as the font is concerned, the best font to use is going to be Courier or Courier New and a 10-point. And that's what I've already got here. You'll notice that I'm using Word in a PC. I'm a PC user. So if you're having any trouble, come to me, ask me to help you out. Dr. Conklin is a Mac user, and things may work a little bit differently on a Mac. So if you're having any troubles with this process, seek her out, because she can help you with that. Now we want to change the name of the header. And you want to make sure that you keep the greater sign, or the caret, because that will maintain the FASTA format that the computer programs will recognize and be able to read. So the unique code that I'm using is A8, and we want to call this the raw sequence. Now I like to pay attention to and keep a track of the changes that I'm making. So I'm just going to copy and paste this whole thing. The first thing you want to do is clean up the ends at the very end. So we just get rid of those. And we also want to clean up the ends at the beginning. So you want to go to the last end that you can find and clean those up. If you find that you have a lot of ends throughout your sequence, then you have a special issue going on, and we'll talk about that in a little bit. So you want to delete any spaces here. If you delete a base, you're going to have to add it back in, otherwise it's going to cause problems. All right, let's now rename this raw cleaned sequence. And the next step is to get the reverse complement of this sequence. So let's go back to the handout. And let's go down to the page where there's the instructions of how to do this. And we're going to go to this website right here. We're basically going to copy and paste our sequence right into that box. So let's go ahead and do it with the header. And just click submit, and it's going to spit out the reverse complement. Copy and paste that and put that back into our document. And actually that is that's the same sequence that we already have. For some reason this happens sometimes. So let's go back and grab that reverse complement one more time. Let's try this again. Okay, that looks better. Let's grab this header. And now we'll rename this reverse complement. We want to double check that we make sure we actually do have the reverse complement. And we can go to the end of the sequence and compare it to the beginning of this sequence. So where we have a GG, we're going to expect to have a CC, and that is the case here. So then we see a T, we would expect to see an A, okay? And then we have 1, 2, 3, 4 C's, and we should see 1, 2, 3, 4 G's. So I'm pretty confident that we now have the reverse complement. All right, we've got one more step before we have our sequence ready for alignment with the reference sequence. We're going to need to clean up some of these bases in the beginning so that the beginning of our sequence lines up pretty much with the reference sequence. And so that small sequence that we need to find here in the beginning, you're going to be able to find that in your handout. So let's go back to the handout and we'll scroll down, and there it is. There's the sequence that we have to locate. Now I cannot copy and paste this, so I'm going to have to go somewhere else to get it. So let's just go to this document that I've already prepared. Copy and paste that right there. And let's actually copy and paste this right underneath. And let's find this sequence now as we work our way across. We want to see the CTG sequence, and there it is, CTG, and make sure that it is actually the entire sequence there. So CTG, TTC, that matches, 3 T's, yep, CA, T, and then GG. We've got it. So we want to delete all of the bases before that sequence. And I'm going to call this the edited. Oops. I'll put edited here. All right. So this sequence is now ready for alignment. If you're unable to locate the CTG sequence in your sequence, and if you have a lot of ends in the beginning of your sequence, you may have what is called a homopolymer sequence. And what you want to try to do is locate that. So that particular sequence is preceded by 4 A's, and then it is a string of C's. So in this case we have a C, 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 C. We've got a T in the middle. And someone who has a homopolymer sequence, that would be an additional C. And then we're ending up with 4 more C's after that. There is another video to help you guys be able to clean up your sequence and do an alignment. Okay, so make sure you watch that video.